Greetings, everyone. Hope everyone is doing well and enjoying their weekend. So, what I wanted to do today was go over um, stages of system engineering, and this is going to be our first makeup video lecture from one of the classes that we missed previously. And I think this is a good timing for this, only because I think it coincides well with your most recent team assignment, which is to generate system engineering or system requirements, I should say, for your projects or your systems. Now, so you guys know, this is directly from the chapter 1 and 2 slides, which should be posted in Canvas. All right? Let me zoom up a little bit here. Okay. So once again, when we talk about the stages of system engineering, it's very similar to the system life cycle. Obviously, we start with the needs, as we discussed early on, and really nailing down your needs. And typically, it's a recursive process that takes at least a few meetings. And as we know, we nail those down, and that kind of feeds into our system requirements, where we can define the system and start actually producing perhaps some type of proof of concept or prototype. And then one area that is really exclusive, I would say, to the system lifecycle is the utilization right here, as we see in section 5, where we basically have to maintain the technology after it's been deployed. And once again, class, I'm going to just hit on some of the highlights of this section, some key takeaways, but I would like you all to kind of flip through these slides. And once again, I think it's at the end of the chapter 1 and 2 slide set. All right, so what are some of the main tasks during the initial phase of system engineering? I think we have a pretty good idea what's being discussed here in these bullet points. One area that I do want to discuss in detail is the system level synthesis and what that relates to. All right, so once again, early on in the project, I think we have a pretty general understanding of the importance of identifying stakeholders, who the system is going to impact, and then identifying and answering some basic questions, as you guys see listed here, 1 through 5. We really need to understand, what is the purpose of the system? What's the need? What's the driving force behind the need for our system, and also what's the cost benefit? We're going to invest so much time and effort. What is going to be our return on that investment of time or money, whatever the case may be? But now, okay, we're at the point where we've kind of defined our needs, but now let's talk about the requirements definition, and this is really where it kind of coincides with your most recent assignment. When we define requirements, obviously we need to understand what the goals are, what we're trying to achieve with the system, and understanding the life cycle, but also understanding the different modes that the system is going to be functioning in, only because if we can define those modes, then most likely we'll have a set of requirements that are specific to each one of those modes. So for instance, if I'm talking about the design of an aircraft, perhaps one of the modes will be to elude an enemy aircraft. So perhaps it needs to be able to achieve certain heights, certain altitudes, certain speed. And so in order to test those, let's call them stressing situations, what are some requirements that relate to that, and what are some performance requirements that relate to achieving those speeds and being able to elude an enemy aircraft? Okay, and also we talked about constraints. That's kind of universal, really, for any project or any kind of system. And then interfaces. So one of the things, or one of the goals of system engineering is understanding the system of systems approach, right? And having subsystems, and okay, one of my subsystems might function correctly, but how does it integrate across the board? Will I lose some kind of performance? Will I lose some kind of functionality? So these are key aspects that we need to keep in mind. All right, moving on. Feasibility analysis, once again, doing that cost-benefit analysis to even see if the design or the system really warrants this type of effort or this type of investment of time and budget. And then we get into system requirements analysis. This is really kind of what we've done. I think we got a head start on this actually when we did that functional flow assignment, the functional flow diagram, to understand at a very high level what are the subsystems, what are the functions of our system, and then now what you're going to be doing with the most recent assignment is actually creating physical requirements. Okay, actually I didn't mention what type of format. If you guys do it in Excel or Word, basically what you would do is just have sections for your subsystems and just start writing maybe a few bullet points for each one and state your requirements. Got some pop-ups here I'm trying to get rid of. Okay, got a new email, great. All right, so continuing on. So defining, so the key aspect, and this is actually something I want you guys to incorporate in your assignment, is what kind of requirement are you actually going to be putting down, right? So you have your functional, you have your performance, and you have verification. And if you ask me, they all kind of tie together, only because for a functional requirement, I might have some performance characteristic of it that ties into it. And then you think about, okay, how am I actually going to verify it? Okay, how am I actually going to verify that requirement to ensure that it meets that criteria stated in the requirement? And we talked about we can build a physical model. A lot of times that's cost prohibitive, and so we have to develop some kind of model or some kind of simulation to verify that requirement for the customer. Okay, and it mentions right over here the functional flow block diagram, so I think that was a really good exercise for us to do early on. All right, continuing on. This is kind of the exercise that we already completed. I think you guys did a really good job of kind of parsing this out. Once again, we have our functions here. We decompose these functions into a system level, and then we start picking each one of those system level functions and then decomposing those to a subsystem level. All right, so we talked about functional requirements. Now we're talking about performance, and as I mentioned, most likely with each one of your functional, you're probably going to have some kind of performance characteristic, right? So like, for instance, if we're talking about an aircraft or we're talking about a vehicle, perhaps it needs to reach a certain speed. So if it needs to reach a certain speed, how much power is needed, how much output is needed in terms of that system. So those things we need to define here, okay? How much acceleration, so on and so forth. And then, as I mentioned, accompanying each requirement, each performance requirement, is a set of these verification requirements. So to kind of encapsulate what I want you guys to do, and I'll try to update the assignment, your latest assignment as well, but I want you to define what type of requirement, okay? So categorize, so not just blindly put in requirements, but what are the type of requirements, functional performance, and then how are you actually going to verify the requirements? Okay, so those are three pieces of information, or it may not even be three, it might be two or three, but I want these to accompany each one of your requirements that you list. Alrighty then, let's continue on. As I was talking about earlier, I wanted to focus on this. I don't think we really discussed this in detail, but synthesis is really understanding. This typically happens early on, but it's kind of understanding what the needs are. It typically happens after the user need. Basically, what we do as a contractor is we do a synthesis research to see is there something currently available, or is there current technology that's out there that we can leverage that might be able to solve the problem? Or maybe there's something that we can buy commercially, what we call off the shelf, OTS, that might save us money and time than having to develop that on our own, right? I mean, maybe there's parts of that system that we don't have to fully develop, which will save us time and money, and resources. And maybe there's, and we can purchase those pieces off the shelf. So different benefits for doing this type of synthesis analysis. Once again, post user needs analysis. All right, and once we complete that analysis, then we can put together what we call our system specification or system spec. And this is really a cumulative list of all our requirements and all the functions of the system. We have a tentative idea of how to design the system. And really what this system spec does is it gives basically a guideline for designers to go out and start producing either a proof of concept or whatnot, or a prototype, and then that goes on to become a detailed design. And oh, by the way, like during that time, there's many reviews. So we have a preliminary design review, we have a critical design review. I'm sure many of you that have taken design already know what I'm talking about, but you will surely encounter that once you take design, and most likely once you're also in industry. All right. What I want to do here is take a short pause, and I need to have some kind of metric to make sure you guys are actually viewing this wonderful lecture, of course, right? So what I want you guys to do is basically write up a paragraph and tell me how you think the concepts that we learned in this class will help you not only academically in your future classes, but also in industry. Okay, so just give me, actually let's go ahead and make it 2 paragraphs, but hopefully we covered enough material that you guys should be able to complete that assignment, and I will put that on Canvas as well. All right, so once again, come up with a couple of paragraphs in terms of how you think the concepts that we're learning in this class will help you academically and also professionally. All right, so let's dive back into this, shall we? All right, so preliminary design. Once again, we're taking what we've defined, and now we're going to start designing. Essentially, is what's going on here. We also do that allocation of system requirements to subsystems. We talked about traceability and why that's important. So for instance, if I'm like a software engineer and I see requirements that have been allocated, I can go back and trace and see, who decided what in terms of me receiving that. And then, I might push back and say, hey, this is not something that we can do in that time frame or the budget that you've given me via the WBS. You guys recall the WBS is really for assigning those resources. So there's different benefits of tracking and using traceability for your requirements. All right. Also, we talked about functions. I'm going to kind of browse over this somewhat, and then we dive into the architecture. For me, this is really about the physical architecture. It doesn't have to be just physical. It can also be, software architecture. It could be anything. But just tell me how those components of your software or of your physical architecture, how they're going to interact, how they're configured, and how they're arranged. So it kind of gives me an idea of how these different components of your architecture are going to interface. And we could even take that a step further and say, okay, by what means are they going to interface? What's going to be that means of communication between those components? And how are they going to talk to each other? How are they going to interact? Are there going to be any issues within that communication? So it's very important, once again, to define the architecture of a system. Configuration items. Here basically what you're doing is you are documenting decisions that are made really throughout the course of a life cycle, from the beginning really until it's in operation. The way that we track these configuration items is called configuration management. Okay, so once again, when we talk about functions, what are some of the major functions at the subsystem level? That is typically categorized as a configuration item. Okay, and so how those are tracked throughout the life cycle of that system is what we call configuration management. All right, the next component here is, so we've basically identified our requirements, our functions, our subsystem. The next step is what we want to do is what's called the allocation or the traceability matrix, which is represented here on this chart. So basically what we have is what are some of the major requirements in our system, and really all the requirements for our system categorized by different areas. So we have functional, we have some requirements that relate to physical attributes of our system, so on and so forth. And then we're trying to basically see where can we assign these in terms of like a subsystem or a configuration item, right? So we talked about configuration items being some of the functions of the subsystems. So if we consider these items here on the top being subsystems, now basically I'm assigning these higher level requirements down to these subsystem level. Is essentially what I'm doing is decomposing my system level functions. Okay, we talked about interfaces, how these subsystems basically interact. There are many different ways, obviously, depending upon your system, but it's important to consider this in design. And once we come to a baseline, right? Once we have basically defined our architecture, we've established our requirements, we've taken our system level requirements and we've allocated them to the configuration items or the subsystems. At this point, what we have is what's called a allocated baseline. Okay, and this is kind of a baseline that all stakeholders use to really get the design going, to really start permeating the tasks throughout the entire project organization. Okay, I'm going to skip over a couple of these slides. One of the other key aspects is changes that occur on the system have to be tracked officially, right? And there's typically a method of doing that. And so one of the key aspects is once this baseline is defined, then any changes to that baseline need to be tracked through what's called a change control board. And typically it's made up of the stakeholders and other people of importance to the project. And so that also has to be tracked. Any action items additionally to that system need to be tracked in some type of control board mechanism. Okay, and then once again, let's see, we're at stage 4. This is really prior to deployment, and basically we have certain key aspects of the system also that needs to be tested prior to release. And then we move to stage 5, where this really is discussing the role of maintenance, the role of system updates. As we know, once the system is deployed, there is this evolution cycle, if you will, of updating the system, modifying the system. But at some point that becomes too costly, and at times the system ultimately times out and it needs to be disposed of, and some type of new technology replaces it. Okay, so that's really all I had for the appendix. But once again, what I'd really like you guys to focus on as I flip back for your current assignment, I'll just go back here, is to really define define your requirements at the subsystem level or at the configuration item level. Okay, I'm looking for at least three. If you can define at least three requirements, and then after you state them in a sentence, and typically what we do in practice in industry is when we define requirements, we use the word shall, right? We use the word shall. So the system shall perform at a certain level, right? So I want you to use the word shall in the requirements that you basically create. And for each one of those requirements, tell me, is it a functional requirement? Is there a performance? Is it a performance requirement? And how are you going to actually verify that requirement? One thing, if you have a functional requirement, typically there is going to be a performance aspect to it as well. So those kind of go together in a sense. But then the key aspect is, how am I going to verify it? Am I going to run some kind of simulation, some kind of physical test, or let's see, am I going to basically do it by inspecting something? So there's different ways to actually verify your requirement. All right, so that's all I had for today. Hope you enjoyed the broadcast and enjoyed this first makeup lecture. I'm going to try to get one more out, hopefully by the end of this week, but at least that helps us to make up one of the classes and one of the lectures. All right, so with that, I'm signing off. You guys have a great day. Thanks.